Okay, everybody, welcome to your next lesson all about synthetic division of polynomials. If you had me for Algebra 1, then you have covered this once before as a bonus skill. And now we are ready to dive right in as one of the two methods to divide polynomials. We're going to talk about synthetic in this video, and then we will talk about long division in class on Monday. So I think synthetic is the easier of the two options. It's kind of like, I don't want to say the cheater's way, but there's some shortcuts that you're going to take, so it's going to be a little bit easier, I think, than long division. But we'll just dive right in. First, we have to make sure that we understand the parts of a division problem so that we've got all the lingo for when we are running through these problems. So you're going to see a division problem written usually one of two ways, either kind of in long form like this with the division symbol, or the big part on top as the numerator and then the little part on the bottom. But we understand both of these as 15x squared minus 7x plus 2 divided by x minus 1. So the thing being divided, or the big part, is called the dividend. Okay? And then the thing doing the dividing, the little part, the thing you're trying to put into the big part, is the divisor. Makes sense, right? Divisor is the thing that is being divided into the dividend. Okay, so now that we have that, we can scoot right through. All right, so we're going to kind of go over some verbal step by step, and then we'll walk through an actual example of a problem. In order for synthetic to work, you've got a couple criteria that need to be met. The first is kind of silly, but you will always remember it. It's what I like to call a naked variable in the divisor. Okay, what do I mean by a naked variable? I mean the variable has no coefficient. And we know in actuality there is a coefficient there. There's an invisible one. But if I'm reading the problem, I want to see just a variable here, a naked variable. Nothing attached to it. It's not wearing any clothes. If we have a naked variable in the divisor, again, in the little part, the thing doing the dividing, the thing that comes after the division symbol or under the bar, okay, then we know it will work. But if you have a coefficient on the x, technically synthetic will work. You have to do an extra step in order to make it work. And if you know me, you know I'm not about the extra step. I want to do it the easy way. I want to do it the quickest way possible. So if you have a coefficient on the variable, then you're going to want to use long division. It's just going to be easier. Synthetic ain't it. But if you've got no coefficient on your variable, then you will be good to go. The other criteria that we have to meet, all degrees must be represented from the leader on down. What do I mean by that? If your variable's in the dividend, so in the thing that is being divided, okay, in the big part, what comes before the division sign or on top of the bar. If the variables in the dividend skip a degree, you must expand to make up for the missing exponents before you can do the division. You have to do this on the front end. You cannot try and make up for it in the back on the end, okay? So 3x to the third minus 2x squared plus 3x minus 8, that works for a dividend for synthetic. We've got a third degree, second degree, first degree constant. 3, 2, 1, 0. 3x to the third plus 3x minus 8 does not work. Why? We're missing that squared variable being represented here. So how would we expand this so that all degrees are represented? Well, 3x to the third stays just the way it is. I need to get an x squared in here. So I'm going to use a 0 as the placeholder. Then we pick right back up where we left off. Our 3x cubed, our 3x, and our 8. 0x squared is the only thing we added in there. If we put this as just x squared, then that would imply that this is 1x squared. That would change the value of this, of this expression. But by adding in a 0x squared, technically 0 times anything is going to be 0. It's as if we aren't adding anything in here at all because we're not changing the value of this expression. We're just expanding it out so that all degrees are represented. Doing so with a 0, make sure that we're not interrupting the balance of this expression, right? We're not adding any value to it or taking any value away. We're just filling in the degree, and it will later be removed by the magic of division, as you will see. All right? So you need to have a naked variable in the divisor, and you need to make sure that all your degrees are represented. If they are not, you must expand with a placeholder. Once you make sure you've got both of those boxes checked, those are my red flags that I say we need to check for. Okay, so once we've checked for those red flags, now we're going to jump right into the steps. I put a little disclaimer here. It will seem like a lot, but once you do it a few times, it will be a breeze. So here we go. Here's our example. I put this nice and big. X to the third plus 10x squared plus 13x plus 36 divided by x to the ninth. All right, we've got a naked variable, and I've got 3, 2, 1, 0. All of my degrees are represented. This will work perfectly. We're going to jump right in. So the first thing we're going to do is set up our new divisor. We are going to take the constant from the divisor. We're going to put it in a little box, and we are going to change the sign. If you forget to change the sign, this whole thing is going to be bad. You will be wrong. So do not forget to change the sign. All right. So we have boxed our constant. We have changed the sign. Step number 2, list the coefficients from the dividend. Don't worry about the variables. Keep everything in the same order. All you're going to do is list the coefficients. You're going to list the numbers. So my coefficient on x to the third is an invisible 1. I'm going to list 1. I'm going to list 10. I'm going to list 13. And I'm going to list 36. Okay? Now, if you have ever had my mom for a teacher, you know that she sings this next step, skip a line, draw a line. I do not. Add singing to the list of things I am bad at, along with drawing straight lines and spelling. But our next step is to skip a line, draw a line, bring a number down. That's what BAND stands for. So we are going to leave room here. We're going to skip a line. We're going to draw a line, and we're going to bring this 1 down underneath the line. Skip a line, draw a line, bring a number down. Okay? Our next step is what I like to call below the line and by the box. Okay? Anything that is below the line, you're going to multiply by the number in the box. Below the line, by the box. So 1 times -9 is -9. And you're going to list that product above the line in the next vertical. Place that product above the line in the next vertical over. Okay? You with me so far? Let's recap what we've done. We've taken the constant from our divisor, we've boxed it and changed the sign. Then we've listed out all of our coefficients, skipped a line, drew a line, brought this number straight down. Now what was below the line, we multiplied it by the box. We placed it in the next vertical. And now we're on step number 6. If it's above the line, you combine. You guys are all too young to remember the O.J. Simpson trial, but this reminds me of if the glove don't fit, you must acquit. So we can talk about that in class. But above the line, you combine. 10 plus -9 or 10 minus 9 is going to give me a 1. What happens when you're below the line? You multiply by the box. You're going to fill it in the next vertical over. Okay, we're down here on step 8 now. We're just repeating the entire process until we've reached our last vertical. So what's 13 minus 9? Or 13 plus -9? I hope you said 4. All right, below the line, we multiply it by the box. What is negative 9 times 4? It's negative 36. 36 minus 36 is 0. Okay, cool. So are we done? No, we're not done. We went from something with lots of x's to just numbers, and this doesn't mean anything until we fill in our variables. Okay, so we've got 1, 1, 4, and 0. We need to fill in our variables. So we're going to take the leading variable, oops, let me switch this down so you can see, the leading variable from the dividend, and we're going to drop it down by 1 degree. Why are we doing that? Why are we dropping it down by 1 degree? You guys remember, when you are dividing exponents, you subtract, right? Just like when we were multiplying the same bases, we added the exponents. Well, we're doing the inverse operation of multiplication. Now we're dividing. So it would make sense, it would stand to reason that we would do the inverse operation on the exponents. If we're dividing the bases, we subtract the exponents to give us x squared. So essentially, the first thing we're dividing here is x to the third divided by x to the first. So our quotient then, our answer would be x squared, which is why in synthetic division, which is just a nice big old shortcut, when we start to fill in our variables, we go 1 degree down from the leader. So I'm going to start here with an x squared. Next over, I'm going to put a single x, an x to the first. My 4 is my constant term, and the last term is going to be the remainder. Luckily, our remainder is 0, which means we don't have a remainder. Our answer is just x squared plus x plus 4. That's it. But let's say we did have a number here. That means that that number would be the remainder. And if there is a number here and you have a remainder, then you have to write it as that number divided by the divisor. So if there were a number there and we did have a remainder, that is how you would write it. Okay, let's just say it's a. Our answer then would be x squared plus x plus 4 plus a over x plus 9. We'll do another example that I think has a remainder, so that'll make it a little more clear. All right. Pause this video and rewatch it, or take a minute to read through these steps if you need a little extra practice. We're going to go on to this next example. All right, x to the fourth plus 2x cubed minus 4x minus 5 divided by x plus 2. All right, let's check for our red flags. We have a naked variable. Awesome. 4, 3, something is missing. I go from 4, from 3 to 1, which means what do I need to do here before I can start dividing? I need to expand. I need to put in my placeholder to represent the missing exponent. So in this case, I need to put in a placeholder to represent x squared. I'm going to rewrite this whole problem. X to the fourth plus 2x cubed plus 0x squared minus 4x minus 5. Now I'm ready to go. I'm going to take my constant from my divisor. I'm going to box it, and I'm going to change the sign. So now I have a negative 2, and now I'm going to list out my coefficients. 1, 2, 0, negative 4, and negative 5. I'm going to skip a line, I'm going to draw a line, and I'm going to bring a number down. If you don't remember to skip that line and you draw your line right here, you are going to confuse the heck out of yourselves. You've got to give yourselves room to create these verticals so that you know what you're combining and what you're multiplying. All right. So we skipped a line, we drew a line, we brought a number down. Now here we are at step 5. Below the line, you multiply it by the box. That's going to give me 1 times negative 2 is negative 2. Anything above the line, you combine. 2 plus negative 2 is 0. 0 times negative 2, also 0. 0 plus 0 is 0. 0 times negative 2 is 0. We're on a roll here. Negative 4 plus 0, negative 4. Negative 4 times negative 2 is going to give me positive 8. And negative 5 plus positive 8 is going to give me a remainder of 3. Now I need to fill in my variables. I go to that leading term with the 4th degree. I got to bump it down by 1 degree to give me x cubed. And that's what I fill in for my first variable. X squared, x, and then my remainder over x plus 2. So let's rewrite this a little bit. When we rewrite and clean this up, I do not write anything that has a 0 as a coefficient because it's not there. It's an empty value. 0 times x squared is 0. 0 times x is going to be 0. No need to write 0. It's a waste of time and energy. I'm going to write x cubed minus 4 plus 3 over x plus 2. That is my quotient, or my answer, for x to the 4th plus 2x cubed minus 4x minus 5 divided by x plus 2. Okay, and you can see that original expansion that we did, that placeholder with x squared, didn't make any difference in the change of value because we don't even have an x squared down here. Like I said, the magic of division. Okay, that's synthetic division, you guys. I know it seems like a ton of steps, but in actuality, it's quite simple. It's a major shortcut. As long as you can remember to check for your red flags. Remember, skip a line, draw a line, bring a number down. Below the line by the box and above the line combine. You guys will have no problem. I realize that I just listed like 4 of the 9 steps as things to remember. But once you do this a couple times, you will have it down pat. It'll be habit. You can do it with your eyes closed. I know it. If you have any questions, write them on your question sheet so that we can talk about it in class tomorrow. Otherwise, great job and get ready to practice.